right, well, Algebra 1, this is section 8.3, and section 8.3 is a bit of a challenge. We learned what the components of the quadratic formula did, or the quadratic equation, the f of x is equal to ax squared plus bx plus c, did in sections 8.1, where the a, vertical stretch, compression, upside down, right side up, and then the c was simply how far up and down it lifted the vertex. However, now that b has entered the picture, things have changed. So let's have a look at what we got. Okay, so now that we have all the parts, things change. Given that this f of x is equal to ax squared plus bx plus c, that's the general quadratic, this is what we can conclude. If a is bigger than 0, it's still going to open up. If a is less than 0, it's going to open down. Notice that if I just have simply f of x is equal to ax squared, notice the vertex is at the origin. Or if I have f of x is equal to negative ax squared, the vertex is at the origin, but now it just opens down. All right. Now, C. If you take that general form of the equation, and if I load a 0 for x in the ax squared spot, and if I put a 0 in for x where the bx spot is, well, 0 squared is 0, and a times 0 is 0, plus b times 0 is 0, and all I have left is c. So I can safely conclude that if x is equal to 0, then c is the y-axis intercept. So you can look at that number hanging on the end, and that's where it will cross the y-axis. So C is now the y-axis intercept, because if you let x be 0, then there it is. You got nothing left but C. Okay? All right. Then the x-coordinate of the vertex. Remember, the vertex, right there. It's the lowest point of the parabola if it opens up, and it's the highest point of the parabola if it opens down. That's the vertex. All right. The x-coordinate of the vertex can be found using this equation, and you're going to need that. X is equal to negative b over 2a. So you go to your quadratic, you take the coefficient in front of the squared term, that is a. The coefficient in front of the single term, or the linear x term, that is b. Take the opposite of that. Okay. And since the vertex is on the axis of symmetry, the equation for the x-axis symmetry is x is equal to negative b over 2a also. So this will give you the axis of symmetry that is also the x-coordinate of the vertex. Okay? All right. So let's look at f of x is equal to negative ax squared, and f of x is equal to positive ax squared. Again, there it is. Negative opens down. Now the vertex, that is a maximum value. That is the greatest value of y that this parabola will ever encounter. If it opens down, is at the vertex. And if it opens up, the opposite is true. The vertex is at the very bottom. If you were a BB on the inside of that, you would come to rest at the vertex. Okay, that's the minimum value. Now later we're going to talk about the function is increasing and decreasing. I'll bet you can look at that. Where are the y values getting bigger and where are the y values getting smaller? And over here, where are the y values getting smaller and where are they getting bigger? I suppose if I'd have labeled them axes, you would have been able to figure that out. Okay, anyway, well, let's have a look at example number 5 in your text. Example number 5 is 2 water balloons. Okay, we're launching water balloons. We got those big bungee cords and we're throwing balloons around. So they give you the equation of the first one. F of t, time, is equal to negative 16t squared plus 80t plus 5. Now you remember, we've dealt with this equation before, where the 5 on the end, that's your initial height. There's your initial velocity. That's your constant. So here we go. I identified my a is negative 16. Again, it's the coefficient in front of the squared term. B, right there, that's the coefficient in front of the single term. Notice it has a 1. And then C is just the number hanging on the end, okay? So I sketched a little picture. Here is the height, And here is the T, and that's the balloon going splat. Anyway, launch the balloon, it goes up, it's going to hit some kind of a maximum value, then it's going to come back down, okay? This is not a distance, this is a time. Remember, this is height. I don't know how far it really went. We'll figure that out later. All right, so I've identified my A and my B. At time 0, the balloon is 5 feet above the ground, 5 feet above the ground. The maximum height of the parabola is the vertex. There's the maximum height. I've already got it figured out. How did we do that? I'm about to show you. All right, so x is equal to negative b over 2a. So negative 80 over 32 reduces to negative 10 over negative 4. Anyway, it comes down to a positive 5/2, or x is equal to 2.5 seconds. And actually, that should be a t. Let me fix that. There, t. Okay, so 2.5 seconds. That's the x-coordinate right here. That's the x-coordinate of the vertex. To find the y value, remember, I can take the f of x out and I can throw a y in there. Y is now equal to negative 16 times 5/2 squared plus 80 times 5/2 plus 5. Anyway, there it is worked out for you. And you get the height at 105 feet. So, in this equation, this says that this water balloon will reach a maximum height of 105 feet after 2.5 seconds. Now, the question is, which balloon went higher, balloon 1 or balloon 2? So, to get the picture for balloon 2, there's the curve for balloon 2. Well, if you look at the blocks, they're 25 per block, aren't they? So it looks to me like balloon 2 significantly out-heighted balloon 1. Would you agree? I think so, because this actually looks like about 100 and a little over 125. And sure enough, that's kind of what they tell us. See, they graphed it out, but we're smart enough to draw a picture, aren't we? All of you are. Anyway, so the second balloon went higher. All right, wasn't that fun?